Everybody, good afternoon. I hope y'all had a good lunch break. Y'all, give me a second as I let more of you in. Welcome, welcome. Happy Sports Day, I think it is. All right, let's go ahead and check what we have here. It is January 27, and our check-in question today is: do you take naps? So I'm actually genuinely interested, like in general, like do naps help? So are you the type who takes naps throughout the day, or are you the type of person that like naps kind of messes up your routine and your sleep schedule? So that's our check-in today. Go ahead and answer that in the chat, and I could double check who we have here today. All right, I see a few things there in the chat. All right, let's see. Let's see what y'all are thinking about naps. So we have a good amount of yeses in the beginning. We have one in the private message saying they love naps. We have some sometimes yes, sometimes. So mostly we're leaning towards yes. We take naps. We have some no. Naps are the best. I have as a direct message. Nope. Yes, yes. So it looks like majority are in the yes. I just know when I was younger, if I took a nap and I didn't set a timer, I would sleep for like 2 to 3 hours. And I probably to avoid that, I stopped taking naps. And I do take naps on Sundays. I don't know why, but Sundays are, I take a nap in the afternoon just to catch up on sleep. Yeah, naps. All right. So pro naps, that's good. As long as it makes y'all feel energized, woken up, and all of that, then it's awesome. Awesome. All right, y'all. Thank you so much for sharing. Let me go ahead and see who we have here today. And it was mostly based off the the check-in question. This is who I'm missing. So I am missing Kalia, Justin, Ernesto, Anna, Jonathan, Jimena, Amara, Simia, and then Sakaya. So that's who I'm missing today. Again, if you're friends with any of these folks, if we could send them a message to get them to come on in. Our pre-calculus class is like second to last day you have. So it's this day and then tomorrow, and then that's the end of the module. So that's gonna be wild. All right, I'm gonna go ahead and enter this. So again, that's Kalia, Justin, Ernesto, Anna, Jonathan, Jimena, Amara, Simia, and Sakaya. Let's see the chat. So it could be that I missed somebody. Nope. Okay, awesome. We just have yes, yes on the naps. All right, so I'm gonna go ahead and hit submit. So it might, because we're gonna be in groups today and tomorrow working and talking about the mini final. So it may be like, if we have more people tomorrow, right? It just might you might get more people added to your group, or I'm gonna see how I kind of balance that out. But let's go ahead and talk about what we're doing today. I just took the attendance, and today we're going to be having a group start on the mini final. Now, the other day on Tuesday, I assigned you to submit a draft of the mini final, and a draft is basically your first attempt, kind of like you just trying your best on it and submitting what you tried. But now we're going to be looking at it together as a group, and y'all are going to be putting your ideas together and even creating something better. But remember, at the end of the day, the final draft is going to be due Thursday. So that's your final version. Everyone's going to submit their own copy, right? So what that means is as you're working with your group today, when you're like creating evidence, graphs, anything like that, make sure you take screenshots and start adding some evidence into your mini final. Because remember, our focus, this module is on math justification. Like, how are you making connections to a graph, table, whatever it is that your group is going to be doing today. So just make sure you take some screenshots while you're at it. And then group feedback, basically, that's when I bring groups together and I kind of give feedback. So I'm actually anticipating, like in the middle of your group time, that I'm going to bring everyone together to address misconceptions, and then I'll send you all back. So that's what I mean by group feedback. And then we do have a checkout question if we have time. Does anyone have any questions though about the mini final or about anything else like that? Feel free to let me know in the chat, or you can unmute. All right, if no one has any questions, we're gonna be prepping to get into our groups. Um, and before we do that, I know I presented to you all these essential questions the other day. So I asked you to think about this when we were doing the other day's lesson. I asked you to think about, how can I determine how fast an object is going at an exact instance? And I put the answer there in red. So how we're able to determine how fast something is going at an exact point in time is, what you do is you choose points that are super close to the point that you're interested in, point of interest. And all you got to do is find the slope between those two very close points. So that is the answer to that one that I asked you to think about the other day. Nextly, how is the slope of a function connected to speed? So basically, the steeper the slope, the faster the motion. The other day on the Padlet, you all were looking at how the secant line was changing as our points were moving closer and closer together. Many people were saying that the slope got steeper, and it was getting steeper as in it was getting more negative. But if we were to just look at speed, which is the positive of velocity, um, the speed is getting higher. So the steeper the slope, the faster the motion. And that's true for the picture we looked at yesterday as well. So those are the answers to those things that I had you all think about first off. And you might be applying this in your mini finals. That's why I'm bringing this back up. Let me know if anyone has any questions about this part right here. And I see something in the chat. Let's see. I don't know what the question is. So what it about? Are you talking about the mini final? You'll be checking that out in your groups today, if you haven't yet done the draft on Google Classroom. Yeah. All right, cool. If no one has any questions about the answers to the essential questions that I asked you guys the other day, let's jump into getting a dig into the mini final together as groups. So we do have some people absent, like I said. So like if your group is not 100% there, just try your best. Um, and if no one in your group is able to screen share, you should be. So you want to get on the laptop. But if for some reason we can't, right, I'm gonna have to move you into groups that can. So that's just a way to problem solve that, like in a way that it's not overwhelming for us. Once you are in your groups, the Desmos link for getting started on a group as on the mini finals on Google Classroom. And again, only one person needs to log in. So we're gonna have like 4 to 5 groups logging in. And when I'm popping in, just make sure that you're sharing your screens. I remember when I'm popping in, I'm mostly there to observe, not really to kind of help direct the group. I just want to see your thoughts so far, because I'll bring everyone back together. So that we can discuss it. And that's okay if we keep, if your computer is lagging, just try your best. All right, let me know if anyone has any questions about what I'm about to do. I'm gonna go ahead and begin making the groups, everyone. So give me a sec. And if any questions pop up as I'm doing this, feel free to ask in the chat, or feel free to unmute. So let's do this. And now try to make the groups here. Okay, so it looks like there's only like, so there's a few that, just a few groups that need to be combined because not everyone's present. So I'm gonna go ahead and start moving this. I know right now you don't see it, but I'm taking a look right now. We got room 1. Go to number 4. Go to number 4. All right, so I balanced the groups as much as I could right now. So I'm gonna go ahead and hit open, y'all. And again, Only one person needs to go to Google Classroom, open up the link, share your screen. If you have any issues, I'm going to be popping in to see if that's the case. I'll have to move people around if it is the case. But all right, everyone, good luck. Let me open up the rooms. Oh, we do have someone assigned. Wow. Go ahead and join there. I'm going to start creating groups for the rest that I did not get to assign. So I'm going to go to group 3. Where are the links? Yeah, my bad. If you're still here, that means we still need to assign you. So give me a sec. Let me start assigning us into the groups. Group 3. And then Jose, you're usually, I forget who I usually place you with. Let's try this. All right, I think I did the best I could. Let me know if there's any troubles. So I think Shakira and Fabiano, unless y'all have any preference, I put you in some groups at random. Shakira and Fabiano, do you see an invite? All right. Fabiano, make sure you join your group.
Copy that one.
Okay. Oi. Timekeeper.
Miss Sedano, do we go to the skating speed limit, or is it called oh wait, summative mini project solution for Oakland?
No, skirting the speed. It should show up too once y'all get started on this. Once y'all decide on your book stuff, it's gonna pop up to remind you what we're looking at. But it's called skirting the speed limit. Yeah.
I was riding shotgun and I checked the odometer reading every minute. I use that to calculate our speed, and I can tell you but I can tell you that we never moved faster than 75 miles per hour. Besides, said the driver, Missy, I downloaded the odometer log for that whole drive, and our motion followed the formula. What that formula? I gotta read that.
You don't have to.
When d is distance measured in miles and t is the time measured in minutes, sine functions average out to 0. So our average speed
Feel free to review. All right, we got that. You are a traffic court judge. Two math teachers have appeared before you to dispute a speeding ticket. I followed them on southbound 101 for 9 minutes, says the CHP officer. They covered about 4 miles during their time. At what point I measured them.
Something like this.
Which big idea is that one?
Yeah. This one is 5.
You use number 5 to get your answer.
Yeah, but I think it's like you're supposed to do it like that. But I'm not sure.
Mm,
Kevin put in the chat like the one he did.
oh, let me
Look,
see.
check it out.
Oh, I didn't see. Hold on. Mm,
Oh,
hmm? I don't get it.
Kevin, can you please explain to us your thought process?
I
Uh,
I thought we were supposed to graph it, right?
also,
y 0.5, and then for 2 1 for 2. Yeah, the x2 and then y1. Because they said they were going by 0.5 every minute. And continue that down the whole table until we reach 9 minutes.
Bro,
Right,
Jason,
you want to make a guess? You know,
Rainy, she just explained it. Now he act like he ain't there.
Oh my lord. Okay, so when I had went in the calculator and did 0.44. I had to sneeze. Okay, per hour. I know for the other teams, so 40.44.
Jason, you breaking out.
Green instead.
Okay, hold on.
Yeah, that's a big ass difference from 27.9 miles to the cop saying 75. You know, like wouldn't you think the cop? Like I don't know,
Oh
but
no, hold on. But that's their average speed, right? Hold on.
so probably at that point in time, he probably
Yeah, at that where I highlighted, where I highlighted, right here, like in between right here.
Mm-hmm.
That's where they go,
uh,
they go like 72. That's what I got.
at that steep right there.
Yeah.
Oh, okay.
So yeah, look, like he says, I measured them driving over 75 per hour on radar at one point.
Uh-huh.
So, but back to this one.
Mm-hmm.
Look, I went right here
Mm-hmm.
and I divided that like right here. I divided it and then I got this. Then
So you
multiplied it by
divided it by 27.9.
no, that's my answer. 27.9 is my answer, right?
Hey group, how's it going? Okay, it's going okay. Who was screen sharing here at the last time? Are we having some tech difficulties? Oh, okay. So there's trouble in for DR screen share. Is there anyone else who's able to screen share instead, like Cassie or Angel? Okay. I could come back to this group. So if we don't figure it out, what we could do is just temporarily for today, I'll put you in other groups that are working on it. And then tomorrow put you back in your group. That could be a thing, but I'll come back and check in with this group to see if you all can help. I'm sorry, if you all can problem solve it. If not, I'll be back. So give me like 4 minutes. Yeah.
I don't want to. We're here for 3. We ain't waiting for them. They slow apparently. Consider the graph showing. Oh, go ahead, Jayla. I'm sorry.
Consider the graph showing an ant. What? An ant moving through.
It's like the steepest points of all of them. So it like shows that they're
Everybody, I'm just bringing everyone back to just quickly address some misconceptions before y'all continue working, and then you'll be going back to your group. So give me a sec. I'm gonna wait for everybody to join us. Hi everyone. I think we have everybody back. So this is the point where I said like midway in your group work, I was gonna bring everyone back to address misconceptions. So that's what I'm gonna do right now. And also like make sure that we're going in the correct direction so that you're not too far off here. All right, so first misconception I wanna address is slide number 4. So it said, when you are asked questions about an equation or table, the best practice is to create a model for the situation. And by model, what we should be doing is, so this is Elena's group. You should be just putting down your function. That's the first thing. So we know for sure that this is a model that represents the distance that the teachers drove over time in minutes, right? So this is essentially what you need. Now this here table, I think, is according to what a teacher said, but just because the teacher stated something does not mean it's going to be correct, just so you know, in this problem, in the context. So all we need for this slide is the equation. So everyone should be graphing your function. I'm taking a look, like we're all good. Just make sure, ooh, this one you got to make sure, I think it's like plus 0.2 sine 2t or something. So just make sure you're accurately copying down your function. Let's see, so this one, see, notice how they created a table, but the easiest way to create a model for your situation is literally write down the equation that was given to you in the first portion of the problem. So we know for a fact that their distance is modeled by this function. And this is the function we're going to be using to get our evidence from. So that's the for slide 4. This is what we all need to do is make sure we get this here graphed. So that's just my number 1 feedback. So it's because I saw a lot of groups like creating a table and so forth. But you want to use the function. And again, feel free to let me know if anyone has any questions, comments about that. But yeah, I'm seeing some readjustments. Graphs are getting corrected. Awesome. And by the way, when you're writing on your mini final, remember you want to make reference to models. That means including a screenshot of the model that we're looking at. Now this one looks a little bit off. I wonder what it is. I know this should be like at 0,0, so there might be a typo here. So I would recommend this group double check this one, just for Gottlob's group. Let me just move this. I think it should look, yeah, so there was a typo in that group because I know that at 0,0, so when at 0 minutes, the teachers traveled a distance of 0. Now I see this group is doing something interesting. I have some wonderings, but I know I jumped into their group to see what they were doing with these vertical lines going through. And I also want you to pay attention to the fact that we're only concerned about the teacher's 9-minute drive. So perfect. So basically you're only focused when t equals 0, so time equals 0 minutes, up to time equals 9 minutes. So we're only concerned with this window in time, and you could ignore the rest of the function. So that's just another thing to be on the lookout for. Okay, the next thing I want to talk about is number 5, slide 5, my bad. So this is the first question in your mini final, and it's going to be your job to try to make sure you justify it and back it up. So these are the different responses so far that I'm seeing, the 2 groups, and we only have like a total like 4 to 5 groups. So what is the car's average speed during its 9-minute drive? So overall, its average speed for the whole drive, 9 minutes, and explain exactly what your group did, and then how did you use your model, the graph, right, to reach your conclusion. I also made sure to include this little warning. Make sure your units are in miles per hour. Nina's group here says that the average speed of 4 miles would be a total of 0.44 meters per second. So then, yeah, be careful, because if you go back to the original problem, we're given that the car was going, the distance is miles and time is minutes. So when you're actually finding your average rate of change here, your units are going to be miles per minute, because that's what's given to us in the problem if you see here. So it says distance is measured in miles and t is in minutes. So that's just another thing to be careful about when it comes to your units. But I do like the rest of what Nina's group said. They said we say a total of 0.44 because you get the speed because you divide the distance by time. Yeah. So I like that they're saying divide distance by time, because that is an average rate. That is going to get us an average speed. So they're going in the right direction here. They got 4 divided by 9, and that's how they got 0.44. And they tried to translate that into miles per hour. So, whoops. Let's go ahead and talk about how to correctly do this. And also notice Elena's group also did a rate as well, and they got 0.5. All right, let's talk about how to do this. Okay, so first things first, in order to find the average speed or average rate of anything, you need 2 points. If you look at your big ideas packet, you'll see that you need 2 points in order to calculate the average speed or velocity, right? So I'm just gonna steal someone's graph, a graph that's correct. Let's see. I'll do Elena's graph. And what I'm doing right now is I'm using my graph to kind of figure out the first 2 points that I need. So I need the point 0,0, that's when they start driving. And I need the point 9, 1.85. 9, 4.185. That's the second point that I need. So I would totally like try to hold my mouse there and have another group take a screenshot, because this is evidence using my model. I'm going to be using these 2 points, And I'm gonna find the slope between these 2 points because that's gonna give me the teacher's average speed. So that's what we're gonna be doing in order to answer the first one. And again, I was pulling out where we were at as far as that in the groups. But yeah, so hopefully someone can remind me of the 9 comma 4.185. So just make sure if I forget that number because I'm very forgetful. All right, so in order to find average speed, we need the start time. This is when the teacher started at 0, 0 on the graph. And their end time was at 9 minutes, comma, and I think I memorized it right, 4.185. Keep in mind that this is, these are minutes and these are hours. Minutes and hours. Oh, sorry, minutes and miles. Let's write that down. So this is mins, 0 minutes, and per miles. That's for each of these. So same thing here. So 9 minutes, that's how much miles they traveled. So now what we're gonna do is I'm gonna label my points because, you know, according to the Big Ideas packet or according to our notes, usually when we find the slope between 2 points, we label it. So x1, y1, x2, y2. So that's gonna be our first step. Okay, once we have the start and the end point labeled, we're gonna go ahead and put this in the slope formula. So that's y2 minus y1 all over x2 minus x1. All right, when we do that, we should have y2 minus 0. So it's gonna be 4.185 minus 0 in the numerator position all over x2 minus x1. So just 9 minus 0. So this group was really, really close. So Nina's group, because they did 4 divided by 9. But if we were more precise here, what you're actually dividing is 4.185 divided by 9. Oops, divided by 9, that's a 5. So if we put this in the calculator, right? So I'm gonna use my phone for this. Then right after this, you're gonna jump back into your group. So 4.185 divided by 9, I got 0.465. And be careful here, everybody, because we identified that our units are minutes and miles. So what this is saying is because the Y was on top, this is going to be miles per minute. You have to be careful because we need to take this miles per minute and we need to convert it to miles per hour in order to double check whether or not the teachers, you know, are speeding in their average rate over the 9-minute drive. So what we do here in order to convert it, I'm just going to go ahead and let you all know to use this. All you got to do is multiply this by 60 because there's 60 minutes in an hour. So if we multiply this by 60 min, that's going to give us the 1 hour that we want. And it's going to give us miles per hour. Minutes will cancel out. And so all you got to do is multiply it by 60 and let's see what we get. So I got to do 0.465 times 60. And what I got was 27.9 miles per hour. So on average, that's how fast the teachers were going over their 9-minute drive. That's an average. That's not an instant rate. That's just on average how fast they're going. So miles per hour. So notice how it's incorporating the big ideas here though, because you want to make sure that you explain that in your own, you know, justifications. So again, I need 2 points and I'm going to find average speed. So that big idea connects to average speeds and how to find those, secant line, things like that, our slope. is also connected to average rate of change. So this is all basically average rate of change as our big idea. So when you're explaining this, you want to make sure that you include that. And don't forget to include a screenshot of your model and describe why we chose these 2 points and found the average rate of change or the slope between them. So let's see, does anyone have any questions? I should see some adjustments though. So groups should be adjusting their work here according to what we're seeing here. And or if you have any questions. So do we change our answers? Yes. You should be adjusting your answers as a group if we fully understand how we got the average speed that the teachers went in their 9 minutes. So we should be adjusting it. So maybe someone should take like a screenshot or something, or take a picture with your phone. So again, Nina's group was almost there. Their conversion though was a little bit far, right? They got 0.44, which was close to 0.465. But then you wanted to multiply the number by 60 and you would have gotten very near the 27.9 miles per hour that I got. Great, I'm seeing the slope formula is being written out. So that's super important. That is referencing our big idea of average rates. And again, when you're writing out your answer in your mini final, you wanna make sure you include that step. All right, does anyone have any questions before I release groups back into it? Any last minute burning questions? All right, again, make sure you take a picture of this or something, because once I, X out my screen, my annotations disappear. Don't forget to multiply your answers by 60 because you got to convert the miles per minute. So just make sure you do that. All right, everyone. If there's no more questions, please adjust your answers according to what we saw here, and then you can move on to the next slides. Let me stop my share and let me reopen our groups. All right, everyone. See you soon. Join your groups, everybody. We'll be back in a bit. Jaleel, Ariana, do y'all see a group invite?
Hi, Mr. Donna.
Yay, I think we lost Angel, but was it still hard to do the screen sharing?
No, but we both have it open. I could share it though.
Okay, that's good. Thank you so much. Yeah, I don't know if Angel's gonna come back, but that's okay. Like I said, we should have more people for your group tomorrow. All right.
Wait, it doesn't have to be done today?
Nope, does not have to be done today. So this is just to kind of help you out in your own mini final. So y'all are just trying your best, working on this, and we're gonna continue this tomorrow.
Okay.
Okay.
Thank you.
Welcome.
would be over 1, right?
Okay.
So you can just multiply by 60
Yeah,
since it's over 1, and then that'll get you this,
got you.
right?
Yeah, for sure.
Or
Yeah.
wait,
Yeah.
hold on.
Dude, I ain't understand nothing, bro. But when you like explained it, man, I got it like 0.2 seconds, man.
You didn't understand what Miss McDonald said?
What happened?
You
No,
didn't.
I did. No, yeah, because
Yeah, that's
Kevin
right.
was explaining to it earlier. I had, yeah.
So what now?
It looks like there's so F theory said in the chat, what do y'all think about this one? Whereas like at what point does the speed or the rate look the fastest? Like it's moving quickly. Think about the slopes. Where does the slope look the steepest here? Yeah, I agree with that one. The A, B, the slope was the steeper. And then here for the individual points, which point looks like it has the fastest instantaneous rate of change? So instant rate of change. So we're still looking at a point. So it looks like we're trying to think A or B. Now we're looking at B. What does the rest of the group think? Any thoughts from the rest of the group? Like Ariana, Jaleel, Natalie, or Shakira? Then at S Theory, sorry if I'm mispronouncing your name, let me know. Are you thinking you're gonna stick with point B? Oh, okay. We got something from Shakira there. B because it's the steepest. And it's okay if y'all are using the chat. I'm here looking at the chat if that's what y'all prefer. I'll just say this, like I know Siri was like playing around with which point, like choosing like A or B, but I agree with you, Shakira, that B looks like if I was to like imagine I drew a slope right at B, it would look like it's going the fastest or the steepest at B. So I agree. Yeah, y'all got this. Awesome. I'm gonna pop into other groups, so be back.
Driving for like 9 minutes.
Yeah.
So like we can look from where they started and from 9 minutes to see where like it's the steepest at.
Okay, 9. Let's say it's like right here.
I think like the fastest, probably like from like 0.2 to like 4, it looked like it's the steepest. That's probably
Yeah.
what they was going the fastest. But I don't know how fast it was going.
It was at 4.
Oh yeah. I don't even know.
That's actually pretty spot on. Yeah. So we're looking for where it's the steepest. So that's correct. That's pretty awesome. Also, y'all, you could use so if you go back to that Desbo slide where you were on, there's like a little tool. It says you can check for the steepness of slope. So let's see if we click there what that tool can kind of offer us as we're trying to figure out where the slope is the steepest at. And that's the point that we're going to try to zoom in on. So there's like a little purple line there. That's kind of like a little slope line for you. And you could start to like move that to see where the slope is the steepest. So if the slope, see like how it gets less steep, it gets vertical, it gets more and more steep. You can start taking a look at different points where the
Well, it kind of gets steep in 8 because it's accelerating a little bit more.
kind of gets steep around 8.
Yeah.
And I know Rainey said he mentioned something about like it's doing something similar in 2 and 4. Is that also right?
Mm-hmm.
So then now y'all want to talk about which one looks more steepest out of all the ones that you were talking about. So that means the line is getting like more and more kind of vertical, like very steep. So it's like very, very steep and then it goes less steep. So we're trying to focus on the points that are like very, very steep. Yeah, so super steep, it looks like past 9, huh? But the problem is their trip ends at 9 minutes, right?
Yeah.
But where is like the steepest that slope gets? It gets pretty
Goes
steep around.
past here. Mm-hmm. Just look at it. I would say between 2 and 4. Because if you look at how the gap is between here
Oh, that's a smart
and
way.
then the gap that's between here, 2 and 4.
Okay, so now we just gotta, so it's between 2 and 4 that their fastest speed is at, right? So now let's narrow it down to like a specific point. So kind of what we're doing is we're trying to find at what instant are they kind of speeding or going the fastest the most. And then you all can decide in a group at which point it looks like that's happening. So yeah, I agree. Between 2 and 4, yeah.
So 3.
Around 3. If we click there, what is it says around 3, 1.388. I think that's a good estimate. If your group thinks otherwise, but otherwise, I think that's pretty good.
Yeah, I agree.
Awesome. I'm going to start to bring people back. So just keep that in mind. Tomorrow, we're going to continue to work on this, though. So I'll see you all soon. Main room.
Okay.
Hey, everybody. I'm just bringing everyone back. Taking a look to where groups are at the moment. I only have 8 people, so let me just give it some time.
That was a bit too quick if you ask me.
I'm hoping we're getting most of us back. Welcome back, everybody. First off, awesome job in your groups. Every single group that I was in was super productive. I was really blown away by the group I was in just now. So I might share what they were looking at tomorrow when we come back to this. So we're going to come back to this tomorrow. I did take a picture of the group so I don't forget, because I know it got a little bit switched. So we're going to try to keep the groups as the same as possible tomorrow. So your groups might get bigger if there's more people tomorrow. And we're going to come back and talk about this tomorrow, and I'll give some more directions on the mini final, things like that. I do have office hours right after this class right now, so if you need some help or support, feel free to stay on after. Otherwise, y'all see you. Bye, everybody. Bye.
Bye, Mr. Dono.
Bye. Bye, everyone. Enjoy
Bye.
your day. Bye.